So the chance of things actually hitting each other are so low. They will eventually fall into each other. This is a banger question. Sort of could kind of explain wormholes. I don't know. Yo, what is up? How's it going? Today, we're going to start by reacting to this video called Answering Questions About Time Travel, Solar Sailing, and Galaxy Collisions. I believe the channel is called Space Talk with Neil deGrasse Tyson, yes. And we have some Italian food, 2 different pastas, and a goated meatball. It looks so good.
Let's dive into some fascinating questions, if you do say so yourself.
We'll be the judge of that.
We'll be the judge of that. Yuba City, California.
What kind of city?
Yuba.
Yuba.
It's right next to Yabba Dabba Dooba. Did you ever see the alien take a poop? Is the human connection scientifically essential for learning?
I love that.
Ismic.
All right, we'll get into this later about my opinion on aliens. Well, long story short, they're definitely real, but contacting, we'll have to talk about that.
Asimov's foundation. It is awesome.
Oh, yes.
Gravitational entropy. Flatlanders and 4D space.
Okay, now I'm all confused.
I've seen some of their content before. I love StarTalk. They get so deep. I'm currently studying to be an aerospace engineer, so I love this stuff. So I'm excited to get into this.
This is StarTalk. Cosmic Queries. I got with me Chuck Nice.
Hey,
Chuck.
what's happening, Neil?
All right, this is a grab bag.
Yes, it is.
What's the verdict on how long it takes me to answer a question?
Believe it or not, because they put out this to the audience, they like the longer answers.
The producers.
Well, the producers
data
want us
on
to
this.
go as quickly as possible because they want to get more answers in.
Yeah,
but they asked the people, and the people like the long answers.
And people spoke.
Yes, the people have spoken.
Have risen up.
That's right.
All right. I won't do it on purpose. It's just it's organic when it happens.
It's the passion of the universe flowing through me. This is Alex K, who says, hello, Dr. Tyson, Lord Nice. Alex from Bucharest, Romania here. Bucharest. What keeps me up at night is Flatlanders and 4D space. I often hear...
I love it. That's some geeky stuff right there.
I'm going to be honest. I don't know what Flatlanders is. 4D space, very strange to get into. And I wonder what he'll say.
Yeah.
That's that. We give him a geek award for that.
He says, I often hear that dark matter or dark energy could be the 4D leaking into our 3D space. But living in 3D space, can we ever actually observe a truly 2D space? And if not, wouldn't that mean 4D beings couldn't interfere with our world either, just as we don't notice any real 2D beings?
Of course, it's an ad.
The place you call home is important to you, so it's important to Allstate. Home is where you make all your best memories. Nice work, you two. If it's important to you, it's important to us. You're in good hands with Allstate.
In life, we're all searching for a thing. And when you finally find that thing,
I'm the thing.
you want the whole world to know the thing. So you use Canva to make a thing. Then it becomes a weird squirrel praising movement type of thing. Canva, the thing that makes anything a thing.
I see where he's...
So, let's get into this. So my beliefs, or let's just explain this real quick from my understanding. So 4D space, we live in a 3D world, length, width, height. And it's interesting because a lot of people bring up that like aliens might be in 4D space or in a different like dimension than us. And like when people say dimension, they think of like different universes, like stuff like that. But that's not what dimension truly means in this sense. Um, so oh, let's go. Let's go, Joe. Um, so this guy, Alex, asking about 2D space. Although we can see 2D space, we can see a flat plane. We can kind of interact with it. We can never truly like go into that 2D space either, which is the most like, and you can use that logic to prove on why if aliens were to exist and for us to connect with them, they would have to live in our same dimensions in order for us to see them and interact and all know they're real, basically. But who knows with where technology and all that goes, if somehow we could break the laws of physics to get into that, but we'll see what they say.
Coming from.
Yeah.
I think what he's saying is, if there were 2D creatures in our world, how would we ever know?
Right.
All right. So, holding aside the fact that if you're 2D, you have no thickness.
Right.
If you have zero thickness, how does any light or matter even interact with you? Because light and matter
Reflect.
Yeah. Okay. But
right.
so let's just ignore that very real complication, but let's ignore it for the moment.
Okay.
Okay. There was a cartoon back when the internet was a fun place to just explore humor and cat videos.
We're munching on some Italian. This was more of a spaghetti bowl. And I forget, I'm blanking on the name of this noodle. It's like the flat egg noodles. And then we're saving the big old meatball for last. I'm very hyped about it. So yeah, it's very good. My family went to an Italian place without me to celebrate my mom's birthday today because I had to work during it. Yeah. All right, let's get back into this. But how's your day been, Joe? And if you have any thoughts on what I'm saying or what they're saying, let me know.
Oh, yeah.
There was
Those were the days.
There were two illustrated creatures, and one of them was 2D. I forgot their names. It's like, hey, Joey, I just became 2D. And he's looking at him. He looks a little flat, but he wasn't sure. And all he did was turn sideways, and he disappeared. Disappears.
Right.
He turns sideways towards your sight line.
Right.
And then they laughed, and they were just having a good time. Those were the days on the internet. Man.
Yeah.
Man.
Now it's not.
My whole thing is, you can never really see 2D space because, like, everything we know is technically in 3D. Like, everything, like, paper has a height, graphite and pencils have a height. So it's hard to break down because, like, even at the infinitesimal level, we still live in 3D at all times. Oh, nice. I am actually going to get on Val after this. I don't know if I'll play. I was thinking about doing like because, I mean, I've played Val a few times before, but not a lot. So I was going to do like a beginner type thing into it, but I might, if you're down, I'm down to play, but I'm not good at all. Yeah, let's get back into it.
But Nazis. It's Nazi Yahtzee. Okay.
Crazy thing to go back into. That just took me off guard.
So it implies that even if you're invisible edge on, that the light is somehow still reflecting off of you face on.
Right.
Okay? So a 2D world in front of us would be completely visible. You would see light reflecting off of their substance.
Right.
Their 2D substance, whatever that is.
Right.
Only when they go sideways do they disappear.
Okay.
From your view.
Right.
Because they have no thickness.
Okay.
So we three-dimensional creatures, what would four-dimensional, spatial dimensional creatures be able to see us? It means there must be some orientation we can take where we disappear to them,
Right.
just following this sequence. I can't picture what that would be.
Fair. Don't worry about it though. I'm down to just do my own thing, and I might use it as a recording, and post a video on it. So we'll see.
Yeah, well, yeah, I can't either because I'm 3D. So I'm looking around, everything's 3D. So what do I look like to a 4D guy? I don't know,
I don't know how a 3D person would hide from a 4D person, which way to orient ourselves, the way a 2D person can do that to us. I don't know how you do that. I have to think about it some more. What I do know is, and we've said this before,
I don't know if we could ever actually imagine this. It's almost impossible to imagine like what 4D space really is, and like how a tesseract actually looks and stuff. But it's not even worth getting into.
if you're looking at a 2D creature, you can see inside their organs, their inner organs. 2D people can't see because they have skin, this line, which is their 2D skin. They can't see through the line, but we can see directly into their bodies.
So I look really ugly to a 4D person.
4D person, they'll see all your guts.
They just see guts and yeah.
And I think the first thing we do when we have 4-dimensional beings is to make them medical doctors and have them perform surgery.
Right. It's a game of operation for them.
So they think aliens are 2D or like multiple Ds. Okay. So what the question that was asked was like, hypothetically speaking, according to some laws of physics and just like string theory in general, it proves that there's more than 3 dimensions. So there's definitely the possibility of higher dimensional beings being out there. It's just if we could interact with them or not. But I don't think they're saying like aliens are a specific dimension, like either higher or lower dimension, but I think it's like hypothetical. But yeah.
Nothing to it. Take out wrenched ankle. We're good to go.
I forgot about that game, Operation. I wonder how many people became doctors out of that.
I would love to see a Doodle Bob alien. Oh, that would be awesome.
That's a problem. If they did, they're probably pretty bad doctors. I'm just saying. Like, if the game Operation was your inspiration, they're standing over the operating table with a pair of tweezers. I don't know what to do.
Well, they're trying to settle malpractice suits.
Right.
So that's what I know. And for me, that's the most intriguing thing.
Yeah.
That you can see inside of somebody who's otherwise completely enclosed in skin. In the same way, the 2D person is completely enclosed by a line.
Right. And you can see what's inside that line.
Inside that line.
Right.
So that's the best I can give them on that question.
Okay. Yeah. Well, that's cool, man.
Otherwise, I don't know where to take it.
Yeah. Mm-hmm. All right. Well, this is Jeff Drumsites. And Jeff Drumsites says, greetings, Dr. Tyson, Lord Nice. I recently began watching Apple TV's version of Isaac Asimov's Foundation. It is awesome.
Oh, yes. That's the one where they have the hereditary rulers who are clones of each other. That's the limit of heredity.
That's it.
That's it.
All the lineage is just a cloned line that you have dawn, day, and dusk. So
I've never seen this, so I don't really know what they're talking about, but
and day is the ruler.
Day is the ruler.
Yeah.
Dusk is the wisdom.
And dawn is learning.
And dawn is learning.
Okay.
And they are in that constant cyclical state of replacing one another.
Right.
And at a certain time, they have to be destroyed and move on. It's pretty wild. But anyway, he says this. When I was a child in the 50s, my dad's Popular Science magazine depicted the idea of a space elevator, which they have in Foundation. Trantor is the planet on which the rulers live, and the way you get to Trantor is from a space elevator. So anyway, my question is, he says, is the Trantor Star Bridge or any type of space
You, just you, building your app on base 44.
elevator technically conceivable? Jeff Seitz in Gallatin, Tennessee,
Okay.
or Gallatin, Tennessee.
The answer is yes.
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 But so some things to take note of.
Okay.
The motivation for a space elevator is you can get to an orbit without ever firing a rocket.
Yeah, there you go.
You just, all right,
You just get on the elevator.
get on the elevator.
Third floor, women's lingerie. And where are you going, sir? Oh, okay.
I guess from like it sounds like they're just saying like an elevator from ground level to outer space. I've never really thought of it. I guess main concerns would be like the change in gravity. How do you lift something that's basically in no gravity? Like you need to switch from a pull system to like I guess you could always do a push system. So yeah, I guess it would be a push system, but yeah, we'll let them talk about it.
And is that still a joke? Lingerie? That was the big.
I got it from Bugs Bunny.
Well, okay. The real question is, what is an entire floor doing of just lingerie?
Yeah, exactly.
Nobody's asking that question.
Right.
So I have a friend who composes space music, and she created an album called Space Elevator Music.
That's funny. Right.
Right? On Earth, a space elevator would take you to the geosynchronous orbit, because that's the only orbit that appears to hover over Earth.
Right.
Its corresponding spot on Earth. Any orbit that's closer, it will speed up ahead of the orbit of the Earth.
Right.
Okay? So to have an elevator go from a position on Earth's surface to a position in orbit, it has to go to geosynchronous. And on Earth, that's 23,000 miles. So you'd be sitting in an elevator going 23,000 miles.
Wow.
If your elevator were going 1,000 miles an hour, how long would it take you to get?
23,000 hours.
No.
I mean, 1,000 miles an hour, 23 hours. That's a full day.
It's still a full
It
day.
takes you one day to get, and we already get to space quicker than
Yeah,
that.
I know. That's right. Okay, so the idea was getting to space must be so hard with all these rocket engines and things that we need another way. But access to space now is routine, and the price continues to drop, especially because of innovations in SpaceX. Elon Musk, and it was a big mission statement of his with regard to SpaceX. You hardly hear talk
The renewable rockets are so cool.
of a space elevator
Right,
today.
anymore. Right.
It was a solution to a non-problem. And you know what fuel we're using? Hydrogen and oxygen.
Right.
Well, there's some solid rocket boosters, but the main tank is hydrogen, twice as big as the oxygen tank. And it's liquefied. You put them together, they will combine in H2 and O.
Okay.
So the exhaust is what?
Drinkable.
So, yeah, the exhaust is just water, but it's highly exothermic.
Right.
So space elevators are a cool technological achievement, but I don't see it.
Highly impractical.
I don't see it happening.
All right. Well, there you go. That's but also though, that series it starts off boring as hell, but then it really gets great. So
Nope, that's lame. Ready?
What's happening?
Do you harbor questions about the universe?
We'll skip this.
Some progress. Yeah, some do that.
Vigod in Toronto, Ontario. If a superintelligent extraterrestrial offered to grant you the answer to one specific question, what would you ask? Now, don't think too long because you have to give your immediate response. And we're only here for a few more minutes before their next interstellar train leaves.
How did you achieve interstellar travel so easily? It would be mine. interstellar travel is crazy. Like, our nearest star is 4 light years away. So to get there at the speed of light, it would take 4 years to get to, let alone communicate back. It would be an 8-year gap, counting both ways, for communication. But that also doesn't account for what I think is the most interesting part, the time dilation between that. So the faster you go, the more like time is effective differently. So if you're moving at the speed of light, like a photon, for example, let's say a photon had a brain and like a mind and could see, the photon would see the beginning and end of the universe at the same instant. All of time is in that one instant. Like, if you've seen Interstellar, when they go into the higher gravity near the black hole, like the planet near the black hole, they're in a higher gravity, therefore also a higher like velocity and acceleration. So time moves faster for them. So like in the movie, it said that every second on that planet is a like hour, or I think it's a day on Earth, and they have like a clock for it. So I think that's the hardest part about space travel, would be just the time dilation and figuring out how to get around that. And I think the only way is like wormholes, or like basically teleportation. But so space travel is very hard, and that would be my question.
Okay.
So
There's a question I have every night.
go ahead.
Is the human brain sufficiently smart to figure out the entire universe?
Wow.
That's a question I want answered. Because if it's not, then I'll buffer my expectations.
Right.
But if it is, then
We can
onward
go,
we
can
march.
go from there.
Right.
The universe is your oyster.
Right.
At that point.
It is a React day. Let's go. Welcome in. Dude, I do too. I love black holes. This one, I think I accidentally clicked on the wrong video. But let's go time travel.
But that's a really interesting question, because basically, are we too stupid?
Yeah, I ask that every night.
Like, we might just be like the whole quantum thing, and we're like, quantum.
Right.
Like, maybe we're just dumb.
and it wouldn't be mysterious if we weren't so dumb.
Right.
But yeah, it's obvious.
Yeah.
For these reasons.
Wow.
But we can't even understand the reasons. So, yeah. So I want to know. Inquiring minds want to know.
It's a good question. I mean, I like it. Me? I would like to know, are there cheaper eggs somewhere in the universe than...
Now we got to go help people customize and save hundreds with Liberty Mutual.
What is this?
Maybe where's the golf cart?
Let's get out of this.
where I buy mine right now, because they're hugely expensive.
That's really? That's your question? My son, you can ask any question in the universe.
Right.
No, I can't get ad free. I haven't made money yet, so I got to get an ad blocker. I know it's bad. This is a crazy question to ask. I know he's faking it. I'll get it later, Joe. Don't worry.
I need some cheaper eggs.
Yeah, no. What would I ask if I really wanted to know anything? Mine would be, what happened before the Big Bang?
Really?
Yeah.
Okay.
Like, and I don't mean what happened. I mean, like, because we know what happened before the Big Bang. Who, the Big Bang happened. So what caused it to happen? What was there before? Give me the lay of the land before the Big Bang.
Okay.
That'd be kind of cool to know.
It's an origins problem.
An origins.
Yeah, and origins questions are always the most challenging in science because you don't have other examples to compare it with. And until you do, you kind of making stuff up.
Exactly.
Right.
Yeah.
I mean, what's the origin of the Earth? No one knew until we saw planetary systems getting formed.
Right.
Then we could say, oh, it takes this long with that time frame at this distance from the host star. You can formulate questions that have value. But
the Big Bang is not fake. I can say that with pretty big confidence because we can see it with the farther you look in space. Like and subscribe and I'll give you a black hole. That's what chat says. But yeah, we can actually see the Big Bang, so we know it's real. Question is what came before it. Being it's an infinitesimal like point that all this matter and energy came from. Like was time a thing, all that. In my opinion, I did hydrate 5 times, I swear. But in my opinion, I think what happened was the universe. So there's like the rule of gravity. There's a gravity constant. So however much mass creates this much gravity, we know that that's a fact on all of space. So that gravitational constant is tuned so perfectly that if it was off by like 0.001, all of the universe would either expand so far out that we wouldn't have any galaxies or you wouldn't be able to see anything, or it would all collapse in on itself. So in my opinion, I do think that like the Big Bang was time or like a universe collapsing in on itself due to unright gravitational constant.
Yeah. But it'd be kind of cool if the aliens were, or the terrestrials were just, extraterrestrials were just like, this, your universe is just one of 15 million that we've been to thus far, and before this is what happened. 2 other universes got together after a night of drinking and bang, your universe was born. So anyway.
Can't believe you included alcohol reference to that.
This is Marcus Munzlinger. And Marcus Munzlinger says, hello from Germany. Or should I say, no, I'm not going to do it. I'm not going to do it. Did you ever think, in my accent, pronounce sink, about the alien in Alien not needing any digestive organs, since its blood is acid? So all human flesh it eats is directly dissolved into molecules, so the alien doesn't need to produce poop since it can use 100% of its food. Or did you ever see the alien take a poop? Love your show.
Who knows about digestive tracts? I mean, we played with Superman's digestive tract, and he was an alien.
Yes.
Right?
That's
and
right.
We solved that one, I think.
Yes, we did.
He has a super digestive
He
tract.
has a super digestive tract.
That means
and everything about it is super.
Including the gaseous effluences.
That's right.
Right. A plant-based alien, however, wouldn't have any such waste products. Or its waste product would be oxygen. That's pretty good.
Right.
Right. So I don't, I'm cool with it.
Yeah. It doesn't make a difference. It doesn't.
Right.
A poopless alien is totally fine.
That's right.
I mean, there's nothing wrong with a poopless alien.
But then they have to rewrite that book, that kid's book.
Guys, I'm playing Valorant tonight, not Rocket League. Sorry. Played for 3.5 hours last night. You could go check that out.
Which one?
Everybody poops. Everybody
Right.
poops. This is an old bad dad joke.
Go ahead.
What Italians call suppositories?
No, I don't know.
Innuendo.
Oh, no. No, please. No.
Yes. You know that's good.
Oh, no.
You know it's good.
Oh, man.
Innuendo.
Can you stream Girkmate? No. No, I cannot. Crazy question. I'm not even gonna comment.
Everywhere I go, heads turning, looking at me like, whoa, whoa, whoa. Everywhere I go, heads turning, looking at me like, whoa. Kinda feel like I could go 1, 2, 3, count 'em on your toes.
I mean, this is
Eve Online is a
I don't know.
All right, here we go. This is
Go.
Matthew Landreth, who says, "Greetings, Star Talk. My name is Matt, a globe-trotting teacher who
Nice.
has lived and taught around the world."
Teacher in the house.
There you go. Through these experiences, I have seen how much learning depends on human connection. Dr. Tyson is a fellow teacher and science communicator. You know how ideas ignite in others. Science fiction imagines AI tutors or digital replicas guiding future generations. If an AI could replicate a teacher's knowledge, style, and personality, would that truly be teaching, or is the human connection scientifically essential for learning?
I love that. So, a couple of things. If you are teaching today with methods, tools, and tactics, and then I clone that, I'm not given any reason to think that your clone would not be as effective as you are in those situations.
Right.
You have a life experience, a training, where if someone whose profile doesn't fit that of other students, you will readjust and repackage what you know works so that you have a new pathway to reach the intellectual curiosity of that student. I don't know that AI can do that just now.
He has a point. I can't name one off the top of my head, but I feel like there has been someone throughout history that has learned off of books. It's still human knowledge, but it's not human interaction, which I guess is the question. I do think somewhat like AI and non-human connections will eventually be the normal. Do I think that's right? No. But I think human interaction is necessary in life, but not for learning. Is I guess what I'm trying to say.
Right.
AI can, ape your style.
Right.
It can, dig up some content.
But it can't intuit something different that might be happening in a student and
Correct.
then make an adjustment.
And make an adjustment, especially if students change, they
That's a fair claim.
mature, or they regress.
Right.
Right. So I think that frontier, at least from my foreseeable future, that is the future that I can foresee, remains in the realm of the inventive, creative teacher.
Interesting.
Yeah.
Yeah, very cool. Very cool. The human condition is still a very important part of teaching.
No, it's the ever-changing human
Or
condition.
the ever-changing,
yeah,
yes,
yeah. Because
exactly.
otherwise, I can memorize everything in that moment,
Right.
and then that's watching it go forward in time, and be nimble enough to navigate that. That's the real test.
There you go. All right, this is DJ Sipe. He says, this is DJ from Maine. I've been curious about the properties of space-time and gravity. We know that gravity is the result of objects with mass bending space-time. To me, this implies that space-time is naturally flat, but doesn't explain why. Is there some force or property of space-time that acts to restore its natural flat state once an object and its gravitational field move away? Perhaps some form of gravitational entropy.
This is a banger question, Jake. I'll redeem your hydrate right now. This is one of my favorite topics. So space-time, they say, is like a fabric, but what I think they'll get into is that flat fabric is just what our human mind can intellectually represent this fabric of space-time. So the bending of it from gravity is just like imagined on a 2D plane because we can't see bending in 3D ourselves. But I kind of want to see what he says about why it's naturally flat. I don't know. Let's see.
Ooh, I like that idea.
The idea of gravitational entropy.
Oh, yeah,
right?
yeah.
So he's looking at this whole rubber sheet type.
Yeah. So, I mean, all we can say is, by the way, it's not just matter that will bend space, it's energy as well, because matter and energy are equivalent.
That's right.
Through equals MC squared.
Nice.
So just be more complete addressing it that way.
I know there is dark energy, which makes up like 95% of our universe, and that is not like the driving force, but it explains a lot of the entropy in the universe. So it could be part of this gravitational entropy, but I also don't think it is gravitational entropy because a lot of gravity is centered and it pulls other masses in and other gravities. So
curvature of space
I think it's kind of the opposite, but everything, I don't know. We'll see.
Space and time is the manifestation of matter and energy. If you remove the matter and energy, there's no reason for the space-time to be curved at all. I'm given no reason to think that space would have any shape other than flat after you remove the items that would curve it.
Right.
Keep in mind, however, the expanding or contracting universe itself has a shape unrelated to the gravity of objects it contains.
Right.
And this is why we talked about it as an open universe, a closed universe, or a flat universe. And those are large-scale properties that are not related to just one galaxy or another.
To keep your thing being a thing, you need internet things so
Sorry,
people
guys.
follow your thing.
I really need
And
to
on
know how to
Canva,
know
you can
this.
make all sorts of things that all the people who follow your thing can enjoy.
I gotta send this to
skip it.
Daryl.
Canva, the thing that makes anything a thing.
Yeah.
There you go.
Halfway.
Very cool, man. That's a great question, DJ.
Yeah.
I know. These people are thinking. I love it. This is Keith Johnson from NorCal. And Keith says, can we think of a universal now based on the point of view of an observer? In other words, my now. Can we analyze a particular star in the night sky and determine its probable lifespan and then say that this particular star does not, in all probability, exist anymore in my now?
Absolutely. Because the present is just from the observer. And kind of what they're saying is like the idea of the time travel based off the speed of light not being instant and it actually taking time to travel with how vast it is. So like if we see a star that's millions of light years away, it it could not exist like right this instant that we're talking about. So I think this will be a fast one, but we'll see.
Its ghost is seen as a shadow of light arriving billions of light years after its demise.
So what's the question in there?
So I guess he's saying, is that the case? Like when we look up, are we seeing stuff that's not there?
We see things not as they are, but as they once were. We're not worried if they're no longer there because that's not a real thing we can interact with. We're interacting with a light that is currently reaching us. And when that light was emitted, it was alive, whatever it was.
Right.
So
we're looking back in time, but we're looking at that time.
At that
so
time.
It doesn't make a difference.
No,
Because we're looking at that time.
Correct. It doesn't make a difference.
Right.
So might as well speak of it in the present.
Right.
The star exploded last night. No, it was 1,700 years ago. But what do you gain by that, right? Other than like a nerdy kid saying, "Yeah, you got it wrong. It's not really in the now." So the fun part would be find a galaxy 33 light years away. Find a galaxy 33 million light years away.
Okay.
And then if they all held up mirrors and you looked at those mirrors, you would see the dinosaurs going extinct.
Oh, wow.
Because it's 33 light years there
and 33 light years back.
66 years
so
into the past.
Look at that.
Yeah. So, yeah, it's fun to think that way. But we, our speeds are not high enough to generate significant relativistic.
All right. Well, there you have it. Still a fun question, though. Thanks for the fun question, buddy. All right. That was Keith, and this is Anthony Calamani.
Tony Calamani. Everyone with a Italian voice does not come from Brooklyn, okay?
And they do in my world. All right, this is Anthony, and he says, "Greetings from Seattle, Dr. Tyson, Lord Nice. My 11-year-old son and I were discussing the pitfalls of fictional time travel within the space-time continuum."
Love the 11-year-old saying this.
Okay. Understanding that you have pointed out on many occasions that one would have to calculate not only the space-time location on the target on Earth as it rotates on its axis, revolves around the sun, and the trajectory of our solar system moving through space, but also as our galaxy moves through the universe. Well, he covered it all. Look at you, man.
Well,
this was way to go. Our question is, would one have to know the center or origin point of the universe to guarantee an accurate space-time coordinate, or would relative distances be enough even if the universe isn't expanding in uniform fashion?
Okay, that's an awesome question. So what he's gonna get into, I'm assuming, is that the universe doesn't have an origin point. Everything is expanding from each other. The fabric of space-time is literally expanding itself. It's like if you took a sheet, like an elastic sheet, and like let's say a rubber band was just like a full circle, and you took two sides of the circle, opposite parts, and stretched it out. If you drew a red dot and a blue dot, how would you describe the origin point of how they're moving away from each other? Because if you look at it from red's point of view, the blue dot's moving at twice the speed as what someone from the outside world would see them see the blue dot moving as, and like stuff like that. So it's like it's all based off origin, and like Greek philosophers used to say like we're the center of the universe, and like technically we are, because there's no exact center. I'm guessing they're gonna get into that, but talking about the time travel thing that they were talking about, in order to time travel, and like you would also have to travel through space, because if like let's say we went back, like I decided to time travel right now and I went back 4 months, well, Earth would have orbited to another point in space, and the Milky Way would have moved to a different spot in the universe. So you would also need to calculate that, is what their question is. So I guess their question is, how would you guarantee an accurate reading of that movement?
So he's taken into account the expansion of the universe in the time travel equation as well.
Yeah, but I'm trying to figure out what he's getting at. So
he's saying, I'm going to go and come back. That's what he left out. So I got to go back, and then I got to come back to my time. So
is he going into the past?
Into the past. So my coordinate, okay, what am I going to need? Can I accurately predict with not only rotation of the Earth, but the solar system and the galaxy moving and also the expansion of the universe, can I accurately predict the point where I got to go back and be back in time? I traveled at the speed of light or faster than the speed of light, went back in time, and then come back to that same point where I left.
Right.
Can I do that?
Rich Scott, I think, would say you can.
Okay.
Using sort of mathematical trajectories in the vicinity of black holes. I have to trust him on that because I can't duplicate those calculations.
Okay.
He's studied this stuff like professionally.
Okay.
So in fact, he wrote a book, Time Travel in Einstein's Universe.
All right.
So in principle, yes. But is there a no disruption conjecture where you're not allowed to prevent your parents from meeting, thereby preventing you from being born, thereby preventing you from coming back to try to rectify things? So,
Hey, Marvin.
what? Oh,
I think I got that sound you were looking for, Marvin. No, it's me, your cousin.
so is Marvin? Was
No,
that-
that's right. He was calling Chuck Berry. He's Marvin.
He's Marvin.
It's
Right.
me, your cousin Marvin.
Hey, Chuck,
Hey,
it's me, your
Chuck.
coming Chuck.
Right.
Yeah, Chuck Berry, Marvin Berry.
Marvin Berry.
Yeah, from Back to the Future.
Right,
If you're
yeah,
living under a
yeah.
rock. So, and by the way, I think we talked about this on another episode about gin particles.
Yes, we did, which I
Right.
love.
And so that's a gin song.
No, we did a
What you want to do is save hundreds when Liberty Mutual customizes your car insurance.
That's great, but can you ask?
we did an explainer.
Explain it. So that'd be a gin song.
Gin song. That would be a gin song.
A gin song.
Because it didn't exist until Marvin Berry put the phone out and let Chuck Berry hear Johnny B. Good
The song that he wrote.
He wrote.
He wrote, and then Marty picks it up later.
Right.
I don't know what gin particles or whatever they're talking about, to be honest. But I think it's like saying, when does that song actually start to exist? I guess.
Right.
So Marty gets it in the future, but Chuck gets it in the past.
Right. And,
Yeah.
and so that song was never actually written.
Never actually written.
Right. It just lives in a
It
time
lives
loop.
in a time loop.
Yeah.
I
Yeah.
love that whole gin particle
It's a
thing,
gin-
man.
it's
That's
a gin-
the gin stuff.
It's a gin song.
Yeah.
So
What was the other movie we did that?
it was Somewhere in
about
Time.
A woman with a
yeah, Somewhere
with a
in
piece
Time.
of jewelry or something.
Somewhere in Time.
Somewhere in Time. That's the name of it.
Yeah.
Okay. Cool.
It's a romantic story.
Oh, that's why I don't like it. Okay. So anyway,
I was gonna say rom-com, but it's not a com.
oh, okay.
It's just a rom.
Just a rom.
But it had Christopher Reeve in it.
Oh, okay.
You know, it's Superman.
All right.
After Superman, after he did it.
All right.
But,
Well.
but he's a handsome guy, you know.
Yeah. I mean, listen, they can't all be winners. He did Superman. So anyway, Rich Gott says that this can happen.
Yeah. So I can't follow his math.
Okay.
But I mean, I follow it, but I couldn't derive it. I mean, he's in
You
it.
got to repeat, right?
Yeah,
he does it.
He does it.
He does it.
He figures it out. So I just recommend that book of his.
Okay.
Time Travel in
Time Travel
Einstein's
in
Universe.
Einstein's Universe.
Yeah. Mm-hmm.
Very cool. Great question. And I just like the fact that you're talking to your 11-year-old about the universe and time travel.
That's the best thing. Just how young people are now talking about this. Yeah. I mean, my parents even get freaked out when I talk about space travel and all that. So that's awesome.
Travel in such specificity,
Yep.
which is fantastic. All right, this is Todd Chambers, who says, "Hello, Dr. Tyson."
What a name. That's an awesome name.
Todd Chambers
Yuba City is also crazy.
is here from Yuba City, California.
What kind of city?
Yuba.
Yuba.
It's right next to Yabba Dabba Dooba.
Oh, what's that? 1210 from Yuba? Or what's that? The train?
I don't know.
No, Yuma. Yuma, not Yuba.
310 to Yuma.
310 to Yabba Dabba Duma. Okay, go on.
So he says, I'm a retired naval officer and earth science teacher.
Nice. That's a nice combo
That's
right
a
there.
great combo. Yeah. He says, does light ever do any work? Well, it does light work. No. He says, I'm sorry, I couldn't resist. I had to do it.
There's more coming, so I'm waiting.
He says, does light ever do any
But
work?
it does do windows.
Right.
Okay, they didn't.
And what would that look like to an observer of the night sky?
I'm trying to think about what they're actually asking. So I don't know.
So there's something called a
actually
solar
don't.
sail,
Yes.
where
I don't
you have
know
a
about
big
this.
sort of mylar,
Sorry.
low mass, high reflective. Mylar is like what they wrap around
The
the
balloons.
balloons, are mylar balloons.
Yeah.
And I think mylar might be what they wrap around the
marathon runners.
The marathon run.
Yeah.
There might be some mylar variant.
Yeah.
Flexible, shiny, highly reflective, so it keeps your radiant heat in.
Right.
So it can be warm without it being a blanket.
Like, right.
Right? Because that's all a good blanket does is prevent your heat from getting out.
Yeah.
We did a whole explainer on that.
Insulation.
Like
on
100
blankets.
On blankets 100
Yes.
years ago.
Blanket. I love you, blanket. Okay.
Right. 'Cause many people think if you put a blanket on something, you'll make it warm.
Right.
But no. This has actually been built by funds of membership of the Planetary Society.
That's right.
A good friend of
Bill
Star Talk
Nye.
is Bill Nye, who is the CEO of the.
Oh, I have seen this. I think it's like this sail that tries to capture, like, they call it solar wind, but it's just the energy from light, as like an insulator. Like the blanket, like, catches your heat. The solar sail is trying to capture that energy and light, and we'll see what they say.
Planetary Society.
right.
They funded, built, and launched a solar sail. And the way it worked is because it was a test prototype. So it's orbiting the Earth, and if you want to see if light can do work, you open up the solar sail, angle it in ways to your advantage, and see if sunlight can press on that solar sail and increase your orbit around the Earth.
Oh my god, another ad. This is skippable at least.
And it did.
Oh, snap.
So the light is doing work.
Light is doing work.
Yes.
Wow.
That's actually very cool. The fact that we have this technology is awesome.
Wow.
Okay. And
Reflection as propulsion.
yes.
That's amazing.
Yes.
Oh, that makes sense, but it's weird because light doesn't have a mass. Is one thing that's tripping me up on that. Because usually, like in classics physics, you like always hear about like Newton's third equation. Every reaction has an equal opposite reaction, but that has to do with mass. If mass is hitting each other, it's gonna react like that. So the fact that that's working with photons and light and different particles that are massless, that's awesome.
That's amazing.
Yes.
Reflection as propulsion.
Yes.
That's awesome.
And
That could be how people get up to the speed of light, but that would take a lot of light, and it's hard to, you can't really harness it once you are going like a certain speed.
there's something called the Breakthrough Initiative, which is a chunk of money. Some billionaires participated in this, where it gives awards for new inventions that we think we need, but it just takes some innovative people to do it. Someone wanted, when are we going to have a tricorder?
Right.
Just a portable thing, and then you have all the reading on
there
it. Okay, that's a useful thing. Why not?
So cool.
All right. So one of them is these nanoprobes. So nano means a billionth of. So people have abused the word.
Right.
They just use it for anything small.
Well, that's because Apple came out with the Nano, and that was the end of it.
That was the end. Yeah, there you go.
That was it.
They have these nano cells, so they're like, they fit in your palm. They're like the size of a postage stamp. Attached to it is a huge mylar sail.
Once I'm done.
They get deployed in a rocket launch. Then you have ground-based gigawatt lasers.
Oh, that is amazing.
Beaming these things in the direction you want them to go.
And that propels them forward.
Correct. And the goal is to send these to Alpha Centauri. And you can accelerate it up to like 20% the speed of light.
Yes, because like there's nothing to impede it because you're in the vacuum of space.
You're in the vacuum of space.
And so the laser is
and the thing doesn't weigh very much.
That's amazing.
And the sail is huge, and the laser is powerful.
That's awesome.
Right. So, and you can pack a lot on a postage stamp chip.
Right.
Okay.
Yeah.
Like temperature and radiation field and magnetic field. They can do. And so that's the goal. And so let's see how good you are at math.
I'm not. Let's not.
If it reaches 20% the speed of light, and Alpha Centauri is 4 light years away.
Okay. So
how long does it take to get there?
It'll take 20. Wait, it's 4 light years away, and it's at 20%. So 1 light year would be 1 year. So that's 4 times that, right? No, 5 times that.
Is that your final answer?
Right. So it's 20 years, right?
Okay, now I'm okay. Yes,
20 years. See,
yes.
Now you know how this craziness works.
Okay.
Because that's how I do math.
We just exposed the wiring of your brain in that moment.
I'm sorry. You see how freaking nuts it is up in there, but I come out to the right stuff. But anyway, 20 years.
Yeah, if you go 1/5 the speed of light, and you're 4 light years, it'll be
20.
5 times 4 is 20. Right. So 20 years, that's within people's lifetime who are funding the thing. And so that was the goal. Okay. However, it gets there, now it's to send a signal back.
Oh, well, that's crazy.
Oh, that's at the speed of light.
Right.
So when do you know what it found there? After how much time?
24 years.
Chuck!
Yeah. Super
We'll
cool.
give you an honorary degree.
Wow.
just being on the show.
Yeah, I was going to say yes. Well, you can. You got like 30 of them up there.
No, 27. But
Okay.
This is why I don't think we will ever do this. I mean, one, it will exist in the lifetime. Also, I think it would be 28 because it's 4 there, 4 back. However, besides the point, I don't think it's worth it to do that. I don't think it's worth it to send it there because you're not getting much information back out of it. So I don't think that's where space travel will go. I think space travel is now looking into basically teleportation and travel through wormholes and stuff like that, so we can get around the time. What's the word I'm looking for? Dilation and speed factors and all that jazz.
Nobody's counting. All right. This is Dusty Rock. Dusty Rock Creations. And Dusty Rock Creations says, hello from Quebec, Canada. Quebec. And he says, this is Jean-Francois Roch, who says, here from Dusty Rock Creations. Oh,
you think?
He's dropping names. He says, Mr. Tyson, Lord Nice, let's dive into some fascinating questions, if you do say so yourself. He says,
we'll be the judge of that.
We'll be the judge of that.
All right.
He says, supermassive black holes at the heart of galaxies hold the key to understanding how galaxies come into being.
Maybe. Yes.
Maybe.
Let me tell you why it's a maybe.
Okay.
Because the supermassive black hole has like the big ones, like 1 billion solar masses. Give them 10 billion, but billions. We can Carl Saganify it. Billions.
Right.
So the mass of a galaxy, however, is hundreds of billions times the mass of the sun. So maybe the black hole nucleated some things to begin with, but the mass of the galaxy swamps the mass of the black hole. So there's a limit to how much you're going to credit the black hole for the whole damn the kit and the caboodle.
Gotcha.
Okay. So continue.
That's a very good point. He says, is it fair to say that entire galaxies will inevitably end up being swallowed by their own black holes and disappear forever?
No, I think that's what he's saying. There's a horizon line and a limit of no return and all that in a black hole. The only difference between supermassive black holes and black holes is the supermassive ones are just way bigger. Now that does come with some different properties, but the idea is the same. That's why they're still called black holes. It's because it's so massive that no light can escape, and that's the line of no return, is that horizon line. However, this is kind of like saying, will the planets in our solar system inevitably fall into the sun? And I think more people would say that as a no. And yeah. So I think that's what they're going to get at.
No.
Yep. There you go. Thank you for being my everyday source of wonder.
Oh, thank you. I love that.
Chuck, did you get my name right? I don't know.
Okay, what's the name?
I don't know if I got anybody's name right. I said his name was Jean-Francois Roch, but
R-O-Q-U-E?
R-O-C-K.
Oh, Rock.
Yeah.
Rock.
But Jean, Gean dash Francios. Francois.
Yeah.
Right? Rock. So maybe I got it right.
Probably Rock.
Rock.
Right,
Yes.
I bet it is.
Exactly.
Okay, you did pretty good. I'll give you a B+
Yeah,
on that.
I mean, I did the best I could, but, listen, truth is, if I mispronounce your name, I did you a favor, okay? Because now you got an alias, okay? You got a StarTalk alias.
So here's the thing. A black hole is really tiny relative to the galaxy. They're big. They're like the billion solar mass black holes are like multiples of the size of the solar system. But that's still tiny in the middle of the galaxy. Okay.
Right.
If it's going to eat the galaxy, the matter that's orbiting it has to stop orbiting and fall straight in.
Right.
And that's just not going to happen.
No, it's not.
Okay?
All right.
Whoa. What's that? I just built a budgeting app in Base 44.
Guys.
Maybe stuff nearby. Here's what'll happen. A star will come nearby, and tidal forces will stretch it out, and you'll get this wispy stream of gas spiraling in down to the black hole. Then it can make an accretion disk. That's what we call them. This is where that's the holding place. It's taxiing, ready to go into the black hole. As it's falling towards the black hole, it's slowing down from the friction of all the other material there, and that energy has to go somewhere, and it goes to heating the accretion disk.
Okay.
So hot, millions of degrees, that it radiates ultraviolet and X-ray light. So the X-ray telescopes were the first telescopes to discover black holes, because we did the math on what that should look like.
Right.
Point is, you only get these accretion disks from things that are very close.
Right.
That can be that trip on the matter that'll slow them down. Anybody else doesn't even care that there's a black hole.
Right.
There.
Right. Yeah, it's like when you explain that even if our sun became a black hole.
Correct.
We would still just be orbiting a black hole now that is our sun.
It doesn't have extra gravity.
It doesn't have, right.
Correct.
Because the gravity is due to the mass, and
total
the
mass
does not change.
Yeah, if you turn it wouldn't happen naturally, but if you magic hands to do it.
Right.
That's kind of what I was saying.
Yeah, it would just be a black hole, and if it's the same mass, we'll just still orbit around.
Orbit around that. So now
we freeze to death.
We'll freeze to death. But Jean-Francois actually has made me have a question.
Francois.
So when two galaxies collide, do the black holes then actually fall into one to another and become one giant black hole around that galaxy?
They will very likely eventually find each other.
galaxies are so empty. It's kind of like an atom type of thing where it's like 99.99999% empty space. So the chance of things actually hitting each other are so low. However, the gravities interacting on each other is a very high chance to make a collision. So the gravities will pull each other in. So the supermassive black holes, if they, if one or I guess both, enter another's like gravitational pull, they will eventually fall into each other.
Okay. They will probably, you look at the dynamics of colliding galaxies. Galaxies are mostly empty, by the way.
Right.
I had in one of the questions in the Merlin book where, what are the chances of two stars colliding just in the galaxy? And I said, if there were 4 bumblebees in the continental United States, the chances are greater that 2 of them would accidentally bump into each other than 2 stars collide in our galaxy.
Damn.
Did my brother do true?
That is crazy, but seems real.
2 bumblebees that hit each other had like, you know,
like a little bumblebee hickeys.
But no, just, you know, bumblebee stunned clouds over their heads. So it's empty. So when the galaxies collide, they will pass through one another.
Right.
It'll be this cosmic ballet choreographed by the forces of gravity. And it'll pulse like that as they pass through each other, come back, collide again, and they keep doing this until it settles down because there's energy dissipated each time that happens.
Well, we are bound to collide with the Andromeda galaxy, our closest galaxy. But I think it's 3 billion years, but it might be a little longer until that happens. So we won't be around, obviously, but it's kind of cool that it will happen.
And the settling down puts the heavy stuff in the middle, the heavy, slow-moving stuff in the middle, and the faster, lighter stuff in the outer region. That's when the system is settling.
Right.
And the black holes, they're the heavy thing in the middle.
Of course.
So they'll find each other in the middle. They'll merge, and you'll get a black hole twice the size you had before.
Wow.
Yeah. We got time for one more question.
Oh.
This is a very grab bag. I love it.
This was
it's
a great one. Yeah. This is Patrick. He says, Dr. Tyson, Lord Nice, just another science nerd here from Texas.
Love him.
What if space-time itself is a super solid lattice where defects create natural time loops that erase paradoxes, and the so-called mystery echoes LIGO is hearing are actually the fingerprints of that lattice, meaning we've already stumbled onto evidence of a new state of reality and missed it because we were looking through the wrong lens.
Ooh.
That's interesting. I don't know. We'll see what he has to say.
Ooh.
Wow, Patrick.
I like that. What I like about it is he's thinking of space, the fabric of space-time, as a medium.
You're right.
Okay? And if you think of it as a medium, we sort of already do, but we think of it as sort of fabric rather. Lattice is a stronger entity than just fabric.
Right.
Right? If it's a lattice, then you can think about like crystal lattices.
Right.
And crystal lattices, things happen
They're strong, and yeah, they have properties like he's going to get into.
within them. You know, you can have like light behaves in certain ways in one direction versus another. Sound goes in different ways because the lattice forces energy to pass through it differently depending on the direction that the energy goes through it. And so we would have to propose a series of experiments to check whether phenomena that unfolds within the lattice is different when viewed at different angles. That would be, I think,
Very hard to do. It's going back to the 2D structure, actually. Talking about how like things in 2D could hide from us in 3D if they turn sideways, and then they wouldn't have a dimension. So yeah, I wonder if they'll make that connection.
Based on my understanding of the geology of a lattice, you know, the rock science,
right,
of lattice, of what a crystal would be. So I think he's saying, without saying it, that maybe the entire fabric of the universe is a crystal. I think he's saying that without saying it.
Wow.
And we invented in our lifetime liquid crystal.
That's right.
That's the
your
wristwatches
computer
used to
and,
have.
I mean, not
Like gas crystal or plasma. I still don't really know what plasma is. Like how it's viewed, I guess. Because I know it's a fourth matter. And from my understanding, plasma is hotter than gas. But what does that mean for the particles and viewing, since gas is usually non-see-through? But going back to the crystal lattice thing, it's very interesting to think about, because traveling through a lattice is different. It creates not paradoxes, but it creates reasons for things not going straight and stuff like that. And sort of could kind of explain wormholes. I don't know. I would have to think about it more. But it does create like something to explain why these weird things that we haven't seen or proved pop out from all these equations that prove so much other stuff.
your computer, all your screens.
Yeah,
your
liquid crystals.
TVs.
So this, yeah, I don't have a good answer to that other than that's intriguing.
Yeah.
Yeah.
Well, the universe is a television. There you go.
Back in the day, nobody has the LEDs
now.
not LCDs.
Light emitting diodes, which are better.
Liquid crystal displays. Right.
No more LCD TVs.
Right. Yeah. So anyhow, I like it.
It's very creative. Thought. Very creative.
Very creative.
Yeah.
Maybe you can develop it further.
Yeah, I doubt that.
Why?
I'm just hating.
If he came up with that question,
of course not. No, I think it's brilliant what he came up with. No.
Then we're gonna find out he's a 10-year-old kid.
Now that would be impressive.
Yeah, that would be.
No, it's very cool, man.
All right, so we got to end it there.
Oh man, that was a good one. These people, you people, you're amazing.
Chuck, always good to have you, man.
Always a pleasure.
Yeah.
What a video. Oh, I love outer space and everything about it, obviously, because I'm going into that field. But some good, solid questions. Love 11-year-old being on it. Not on it, but like asking questions like these. That last question, perfectly saved for last. No answer, really. It's a cool thing to think about. And that's one of the coolest things I like about space, is that there's not fully answers, but there is. Like, we know there's an answer, we just don't have it yet, and it needs to be discovered and found out and tested and proved. And there's a lot of things that we can see through equations and different discoveries, but we haven't proven that they're real in the actual universe and stuff like that. Like the difference between quantum versus cosmic and stuff like that. But that's for another time. It was a great video. And yeah, thank you for watching.